In this lecture, I'm going to teach a very important concept of the chapter of permutation and combination. A lot of questions in JEE Advanced and JEE Mains have come in which this concept is used even directly also. To make you understand that concept, first I will explain that concept with the help of this question. In this question, it is written that in how many ways we can get a total of 14 if I throw 5 different dice. Note that the concept I am going to tell you is applicable if it is given that 5 different dice are there. If it says 5 identical dice are there, in that case the procedure will be different. Presently I am supposing that the dice are different. For example, let us take a simplest case of this variety. Suppose he says, in how many ways you can get a total of 8 with the help of 2 different dice. This thing you must have studied in 11th and 12th class, that the possible ways in which you can get a total of 8 with the help of 2 different dice are 2 6, 6 2, 3 5, 5 3 and 4 4. That is, you can get a total of 8 with the help of 2 different dice in 5 possible ways. In the case of 2 different dice, it was not difficult for me to make the cases. But if in the question 5 different dice are there, then it is very difficult to make all possible ways in which I can get a total of 14. Note that the importance of different dice is coming here, that in the case of 2 different dice, 2 6 will mean 2 on first die, 6 on second die, and 6 2 means 6 on first die, 2 on second die. Means I'm supposing that the dice are different. For more clarity, say one die is of red color, and other die is of white color. Suppose I say this is first die, this is second die. 2 6 will mean 2 on this die, 6 on this die. 6 2 means 6 on red die and 2 on white die. That is, clearly these two are different outcomes. But in the case if both the dice are identical, then these two will not be taken as two different outcomes. Then this and this will be taken as same outcome. That is, in the case of 2 identical dice, the number of ways of getting a total of 8 will be only 3. This and this. Because these two are same and these two are same. That is, if we say 2 identical dice, then number of ways of getting a total of 8 will be 3. But presently, I will not go in the detail of those questions in which identical dice is there, because the questions of identical dice are less common. This concept is used in permutation, combination and probability also. And the interesting thing to be noted is, in the questions of probability, even if the dice are given to you as identical, even then for getting the correct answer, you will have to suppose the dice are different. I know that most of the students will not be able to digest this, that in most of the questions of probability, even if the dice are identical given by examiner, you will have to calculate the answer supposing that the dice are different. But in present lecture, it's not possible for me to go in the detail of that. I have just told you the difference between approach of identical dice and different dice. clearly it is very difficult to find all possible cases of getting a total of 14 with the help of 5 different dice by writing all the ways. To understand the proper way of doing this question, I do the previous question in which I was saying in how many ways I can get a total of 8 with the help of 2 different dice. That question I will do by a way, and the benefit of that way will be that with the help of that way you can do any question for any number of dice. That is, even if the 5 dice are 5 or 7 or 10, it makes no difference. It will be very easy to calculate. But to write all possible ways and count them is very difficult. That is applicable only for 2 or at the most 3. But even for 3 or 4 or 5, any number of dice, I will prefer this way which I am going to tell you now. Let me do the question of total of 8 if I throw 2 different dice. To do this question, let me write an expression, and that expression is I write t to the power 1 plus t to the power 2 plus and you can see very easily when these 6 terms will be multiplied by those 6 terms, you will be getting 36 terms as a result. But it is also clear that there will be so many terms which will be identical, and you can add those terms. What I mean to say, if I multiply these two, the least power of t will be 2. But when I will have to write the term t to the power 3, t to the power 3 will be coming 2 times, because when this will be multiplied by this, or when this will be multiplied by this, t to the power 3 will come. That is, t to the power 3 will come 2 times. Therefore, 2 into t to the power 3 will be there. Suppose I want to find the coefficient of t to the power 4. T to the power 4 will come when this will be multiplied by this, or when this will be multiplied by this, or when this will be multiplied by this. That is, t to the power 4 will come 3 times. Therefore, we will be getting 3 t to the power 4, and the maximum power of t will be 12, and t to the power 12 will come only one time. And similarly, you can calculate the coefficient of t to the power 11 also. Just for clarity, if you want to calculate the coefficient of t to the power 11, it is clear that t to the power 11 will come when this will be multiplied by this, or when this will be multiplied by this. That is, t to the power 11 will come 2 times. Therefore, 2 t to the power 11 will be there. Now you can see very easily that coefficient of t to the power 4 is 3. And you know that if I throw 2 different dice, 4 can come in 3 ways with the help of 1 3, 2 2 and 3 1. Let me give attention only to the term of t to the power 4. You can see very easily when this term will be multiplied by this, t to the power 4 will come. There will be terms before also, there will be term afterwards also. When this will be multiplied by this, again t to the power 4 will come. When this will be multiplied by this, again t to the power 4 will come. That is, every term t to the power 4 is indicating towards a way of getting a total of 4 with the help of 2 dice. This t to the power 4 has come because of the multiplication of this and this. you can say in this way also that this t bar 4 term is indicating towards the outcome 1 3. This t to the power 4 has come because of the multiplication of this, and this is indicating towards the way of getting the outcome 2 2. Similarly, when this will multiply with this, again t to the power 4 will come, but this t to the power 4 term is indicating towards the outcome 3 1. That is, when you will add them, you will get 3 t to the power 4. Now, see the main thing which I am going to tell you now. My main aim of teaching all these things was the coefficient of t to the power 4 is indicating the number of ways of getting a total of 4 with the help of two dice. That is, in the multiplication of these two, coefficient of every term indicates towards the number of ways of getting that power of t. I know that by now you must have understood. Just for more clarity, suppose I want to do this question. In how many ways I can get a total of 8 with the help of two different dice? Now let us find the coefficient of t to the power 8 in the result of multiplication of these two brackets. 1 t to the power 8 will come because of the multiplication of this. One more t to the power 8 will come because of the multiplication of this. One more because of the multiplication of this. One more because of this, and one more because of this. That is, you can see very easily t to the power 8 will have coefficient 5. The term t to the power 8 which will come by the multiplication of this and this, that t to the power 8 term will indicate towards the outcome 2 6. One more t to the power 8 which will come because of the multiplication of these two, that is indicating towards the outcome 3 5. That is, I mean to say, every t to the power 8 which has come after multiplication of these two brackets, every t to the power 8 term is indicating towards an outcome. Hence, the coefficient of t to the power 8 will represent the number of ways of getting a total of 8 with the help of two different dice. And now let us do the original question, in which it was given that in how many ways you can get a total of 14 with the help of, if I throw 5 different dice. With the help of previous explanation, now you can see very easily that power of t are the numbers on the die, and because on both the dice 1 2 3 4 5 6 were there, and therefore in both the brackets I have written t to the power 1, t to the power 2, t to the power 3 4 5 6, and I have written bracket two times because I was throwing two dice. Obviously, when I will be throwing 5 different dice, then to get the answer, I will have to write the expression that find the one, 2, 3, 4, 5, 6 have come because on the faces of die 1, 2, 3, 4, 5, 6 are there. Power 5 has come because I am throwing 5 different dice, and I am finding the coefficient of t to the power 14 because I want to find the number of ways of getting a total of 14 with the help of 5 different dies. Means my question now reduces to the question of algebra now, that you have to find the coefficient of t to the power 14 in the expansion of this. For this, I will not do the normal multiplication because normal way of multiplying is very lengthy. How to proceed further? Now see this thing. First of all, I will take t to the power 5 common. Actually, because I have to find the coefficient of t to the power 14 in the expansion of this, it means I have to find the coefficient of t to the power 9 in the expansion of this, because the term containing t to the power 9 in the expansion of this, when that term will be multiplied by this, that term will become t to the power 14. That is, finding the coefficient of t to the power 14 in the expansion of this or finding the coefficient of t to the power 9 in the expansion of this is same. Therefore, now onwards I will concentrate only on this thing. Now this can be written as 1 minus t to the power 6 upon 1 minus t whole to the power 5, because it is GP containing 6 terms. This is equal to 1 minus t to the power 6 whole to the power 5 into 1 minus t whole to the power minus 5. For the next part, I will say, remember this thing, 1 minus x to the power minus n, where n is a natural number. It is equal to 1 plus nc1x n plus 1 c2 x square n plus 2 c3 x cube and so on. If you don't know, remember this formula. And now, keeping this formula in mind, I write it as 1 minus 5c1 t to the power 6 plus 5c2 t to the power 12 minus and so on. Actually, this term and all next terms are useless. Why? See, because when I will expand this, keeping this formula in mind, I will be getting 1 plus 5c1 t plus 6c2 t square 7c3 t cube and so on. Because I told you that I am going to find the coefficient of t to the power 9, and t to the power 9 will come by the multiplication of this term and this term, or when this term will be multiplied by the term here which will be containing t to the power 9. This term is useless because this term multiplied by any term of this bracket will never give t to the power 9, and all these terms are also useless. Therefore, to find the coefficient of t to the power 9, let me write the term which will come here. T to the power 9 and coefficient will be, see, you can see very easily, when t cube is there, 3 is there. When t square is there, 2 is here. In the question of t to the power 9, see, 9 will be here, and this is always 4 more than this. Therefore, when it is 9, it is sure to be 13. And more terms are also there, but those are all useless. Therefore, the coefficient of t to the power 9, you can see very easily, will be equal to 1 into 13c9 minus 5 into 7c3, and outside will be t to the power 9, and all other terms before, after this and before this are all useless. I want to just concentrate on the term of t to the power 9 only. That is, the coefficient of t to the power 9 is equal to 34 minus 5 into 35, because 73 is 35. This is equal to 715 minus 175. That is equal to 540. Hence, I can say I can get a total of 14 by throwing 5 different dice in 540 number of ways. I know that by now you must have understood how to write the expression to get the number of ways. Still, for more clarity, let me give you one more example. Suppose I say I have a die on the faces of which 1, 2, 3, 4, 5, 6 are written, and one more die on the faces of which 5, 6, 7, 8, 9, 10 are written, and one tetrahedral die on the faces of which 7, 8, 9 and 10 are written, and in the case of tetrahedral die, the number appearing in the bottom of this die, that will be taken as the answer. And I say, in how many ways you can get a total of 17 with the help of these 3 die. I just want to tell you what expression is to be written. Once you have understood the way of writing the expression, further it is not difficult, because after that it is only algebra. And the main thing which I want to tell you is how to write the expression. In this case, if I want to find the number of ways of getting a total of 17 with the help of these 3 dice, I will have to write the expression that find the coefficient of t to the power 17 in the expansion of the product t to the power 1 plus t to the power 2 plus t to the power 3 plus t to the power 4 plus t to the power 5 plus t to the power 6. That is t to the power 5 plus t to the power 6 plus t to the power 7 plus t to the power 8 plus t to the power 9 plus t to the power 10, and further it is t to the power 7 plus t to the power 8 plus t to the power 9 plus t to the power 10. The coefficient of t to the power 17 in the result after multiplying these brackets will be indicating towards the number of ways of getting a total of 17 with the help of 3 dice. When the concerned question will be there, at that time I will tell you how to calculate it. That is only algebra. Main thing was to understand the way of writing the expression. Note that in every case I have supposed that all the dice are distinct. If dice are identical, then the whole theory changes. For example, suppose I say how many possible outcomes are there when I throw 2 distinct dice. It's obviously you will say 36 outcomes are there when I will throw 2 different dice, and it's not difficult to see those cases. Those are 1 1, 1 2, 1 3 up to 1 6, 2 1, 2 2, 2 3 up to 2 6, and the last is 6 1, 6 2 up to 6 6. Clearly these 36 outcomes are possible when I will throw two different dice. But if I ask the same question, how many possible outcomes are if I throw two identical dice? Obviously, in the case of identical dice, this case and this case will not be different cases. These two will be same cases because the dice are identical. In the case of different die, this means on first die 1, second die 2, and this means on first die 2, second die 1. But in the case of identical dice, these two will not be different cases. And hence, in the case of identical dice, total number of outcomes, don't say it is 18 because 36, half of 36 is 18. No. Note that these 6 cases, previously also every case was counted one time, and now also every case is being counted one time. But these two cases of two different die have reduced to only one case. This case and this case have reduced to only one case in case of two identical dice. That is because there are in total this and this contains 30 cases. Half of 30 is 15. 15 plus 6, 21. Therefore, 21 outcomes are there when I will throw two identical dice. But again, it is very difficult to find the number of outcomes if I say I have thrown 10 identical dice and now I say find the number of outcomes, then it will not be possible for us to make this type of table in the case of 10 identical dice. For that, a general way is there, but that I will tell in the lecture of permutation combination. And let me now derive a formula which I will be using very frequently in the questions of permutation, combination, or probability. And that formula says that find the number of natural number solutions of this equation x1 plus x2 plus x3 up to xk equal to n. Means if x1, x2, x3 up to xk are all natural numbers, then how many solutions are there of this equation? I'll prove that the number of solutions are n minus 1 c k minus 1. To make you understand the proof of it, I will make you understand with the help of an example. Suppose the equation x1 plus x2 plus x3 plus x4 equal to 18 is given to you, and he says find the number of natural solutions of this equation. As x1, x2, x3, x4 are all only natural numbers, nothing else is given. Therefore, obviously, keeping the theory which I told you in the very beginning in mind, the expression will be find the coefficient of t to the power 18 in the expansion of, because the only condition given about x1, x2, x3, x4 are that these are all natural numbers. Therefore, we will be writing t to the power 1 plus t to the power 2 plus and so on and power will be 4 because 4 variables are there. And the coefficient of t to the power 18 in the expansion of this will be giving you the number of natural solution of this equation, and I will prove that the answer will be according to this formula, that the answer is 17C3 because n minus 1 c k minus 1 means 18 minus 1 c 4 minus 1, that is 17C3. Clearly this is equal to t to the power 4 into 1 plus t square and so on whole to the power 4. This is equal to, and the coefficient of t to the power 18 in this is same as finding the coefficient of t to the power 14 in this part. That is, my question now becomes the coefficient of t to the power 14 in the expansion of 1 plus t square and so on power 4, that is 1 upon 1 minus t whole to the power 4, that is 1 minus t to the power minus 4. And as I told you the formula in the very beginning, that this formula I told you in the very beginning, keeping that formula in mind, this is equal to 1 plus 4c1 t plus 5c2 t square plus 6c3 t cube, and the coefficient of t to the power 14 obviously will be 14 here and 17 here, because this number is always 3 more than this. 14 means 17 here. That is the coefficient of t to the power 14 becomes 17c 14, or this is also 17c3, and which I told you by formula also that the coefficient is going to be 17c3. Had he told about the number of whole number solutions, then I would have started from t to the power 0 plus t to the power 1 plus t to the power 2 plus t to the power 3 and so on. But a very important thing you should note is, when I was doing the question of in how many ways you can get a total of 14 with the help of 5 different dice, you had seen that I had used this procedure and I had reached at the answer 540. Some of the students may think that that formula we can use here also and we can get the answer without using this lengthy way. Their argument will be, I have to find the number of ways of getting a total of 14 with the help of 5 different dice. They will say, let x1 is the number on first die, x2 is the number on second die, third die, fourth die, fifth die, this is equal to, and total I want is 14, therefore I will be writing 14 here, and number of natural solution of this equation will give you the number of ways of getting a total of 14 with the help of 5 die. For example, they will say a solution of this is 2, 4, 3, 2, 3. This solution is indicating towards the way in which on first die 2, second die 4, third die 3, fourth die 2 and fifth die 3 is there. The argument will be that in this way every solution will indicate toward a way of getting a total of 14, but actually it is wrong, because according to formula, if I find the number of natural solution of this equation, that will be giving you the answer 14 minus 1 c 5 minus 1, that is 13c4. But if you calculate the value of 13c4, you will find that the value of 13c4 will be more than 540. Recall that I had done the question of in how many ways you can get a total of 14 with the help of 5 different die. By writing the expression, find the coefficient of t to the power 14 in the expansion of this. Recall this. And I had got the answer 540. But the value of 13C4 will be more than 540 because in 13C4 many cases have come which should not have been counted. For example, in 13C4, this case, say 9, 2, 1, 1, 1. This case will mean that on first die is 9, second die 2, third die 1, fourth die 1 and fifth die 1. But it is not possible because on any die 9 number cannot come. But if I am finding the number of natural solution, this will be a solution of this. But if I am finding the number of ways of getting the total of 14 with the help of 5 different dice, this way will not be allowed. In this way, there are so many more cases in 13C, 4 number of cases which cannot be taken as the answer of result of throwing 5 different dice. For example, one more is 8, 1, 1, 2, 2, 8, 2, 1, 2, 1 and so many more cases. That is the formula n-1c k-1 is allowed only if on x1, x2, x3 up to xk there is no restriction from upper limit. But we will not be allowed to use that formula for finding the number of solutions in the case of 5 different dice, because in the case of die x1, x2, x3, x4, x5 all will have upper limit that all of them are 6 or less than 6. That is, this formula is applicable only if there is no restriction from upper side in these variables. For even more detail, you will have to see my video lecture of permutation and combination.